Wow.
Good evening, everyone. Welcome to the Popular Astronomy Club July meeting. I'd like to welcome those attending here at the Butterworth Center. And I see quite a few online. Looks like we're up to 21 additional participants online tonight. I see some names too from some of our surrounding astronomy clubs. Welcome into our program tonight. I would like to remind you to please mute your Zoom connection to avoid background noise, particularly during the presentation tonight. Also, from most Zoom connections, you would have the chat feature used if you want to bring up a question during the presentation. There will be a question and answer period at the end of the presentation. We are recording this and we'll make the recording available for those who are members of any of the clubs after the meeting is done. Probably within the next day or two, we'll have that available, and I'll send out a message about that. There we go. Okay, I'd like to move on tonight to our feature presentation by Dolores Hill, Senior Research Specialist for Lunar and Planetary Laboratory at the University of Arizona. Since 1981, Dolores has analyzed a wide range of meteorites at the University of Arizona's Lunar and Planetary Laboratory in Tucson, Arizona, provided technical support, and participated in public outreach for space missions and LPL laboratories. Dolores currently works with sample teams for NASA's OSIRIS REx Asteroid Sample Return Mission, LPL laboratories, and coordinates LPL outreach activities. She's a volunteer coordinator of the Astronomical League's Target NEOS observing program and meteorite section coordinator for the Association of Lunar and Planetary Observers. Dolores has a lifelong interest in amateur astronomy, and near-Earth asteroid Dolores Hill is named after her. NASA's OSIRIS REx mission has passed many milestones in its long journey to study near-Earth asteroid venue, overcoming unforeseen obstacles, including house-sized boulders in its path, pandemics, and potential sample loss after successful sample collection in October of 2020. Important discoveries have been made all along, and tonight, Dolores will enlighten us on NASA's OSIRIS REx, the journey so far, and what to expect next. Dolores, welcome to the Popular Astronomy Club. And I will stop my sharing, and it should be available to you now.
Great, thank you very much. It's quite a pleasure to be here, especially since I grew up in the Midwest, Illinois, Minnesota, Michigan. Oh dear, okay. So I'll go ahead and share my screen. Let's see here. Do that again. All right, let me go back to full screen and then we'll share, because my slides are much better than I am to look at. There we go. All right. And where are we? Slideshow. And we'll start at the very beginning. Okay. Let's see, I'm going to put that down. All right. Well, first of all, thank you so much for inviting me to talk about the OSIRIS REx Asteroid Sample Return Mission. As was already mentioned, it has been a long journey. Our spacecraft mission was actually approved in 2011. And we knew it would be a long journey, and yet it's suddenly here, and we are preparing to bring the sample back in 2023. It seemed like a long time and a short time altogether. Tonight will be a little bit of a whirlwind because I have so much I want to share with you. This mission has been an amazing combination of engineering, astronomy, remote sensing, uh, sample science, and we've learned so much already, and we're still continuing. So I have a lot to share, and I hope I don't overstay my welcome too much here. I'm happy to report that in October of 2020, we collected a good amount of sample of the asteroid known as Bennu. And we're especially pleased because we expect this to be our country's largest sample return since the Apollo missions brought back samples from the moon more than 50 years ago. So it's pretty exciting. And perhaps some of you remember those moon landings and how inspirational they were. So this is kind of a full circle. As I said, the mission team has included experts in optical and radio astronomy, navigation, image processing, remote sensing, spectroscopy, sample science, and then of course, last but not least, meteoritics. So that's what I specialize in, are meteorites. And I'm especially interested in these samples because we're bringing back protected, pristine samples of an asteroid that ordinarily would be completely contaminated by the Earth's atmosphere and water, not to mention heat. So we are bringing back as pristine a sample as we can. So one thing that people may not realize is that the name of our mission is an acronym. It's a pretty complicated one, but it fits because it describes all of the objectives of our mission. The name stands for all of those objectives. So we're interested in origins of the solar system because we selected an asteroid that is very old and of a primitive type because it has carbon-bearing materials in it. And we're interested in the origins of life. We're interested in looking at amino acids and other materials that were important to life on Earth. We absolutely do not, I repeat, do not expect to find life in any of the samples or on Bennu, but we are interested in understanding the compounds that are formed out in space. Spectral interpretation represents the spectrometers and cameras that we have on board that provided information on our asteroid, helped us understand what it's made out of, how it was put together, heat flow, and a little bit about the history of the asteroid as well. Resource identification is very important, as I'm sure you've heard. There are companies out there that would like to mine asteroids. And so our mission was kind of a forerunner to help us understand how to identify important materials on asteroids. Indeed, one of them is actually water. And I'm happy to report that we did indeed find water locked up in the rocks in our asteroid. The Japanese sent a spacecraft to a different asteroid about the same time we did. And it turns out their asteroid has traveled too close to the sun and has been essentially baked out. So we've had an interesting time comparing both of these asteroids. Security. As you know, astronomers scan the skies every night looking for near-Earth asteroids that potentially could hit the Earth. I'm happy to say that the big ones are happy in their orbits and stable and are not a problem, so don't lose sleep over those. But the small ones could sneak up on us. And I have to confess, as a meteorite person, I'm happy when the small ones collide with Earth because they bring us free samples. That's how we learn about the solar system, its history, its formation, and materials that we can't travel to as yet. And last, the stage where we're at now is Regolith Explorer. So all of our instruments on board the spacecraft explored the regolith as best we could. And the regolith is just our fancy name for dirt on an airless body like the moon or an asteroid, but it's very special dirt. And we learned a lot about our asteroid from examining the boulders that were there, the compositions, the orientations of the rocks. But there's some things that we just cannot learn from a spacecraft. And so we planned to bring back 60 grams of material, which is about the size of 2 Snicker bars, to analyze here on Earth in laboratories that require instruments that need a stable basement to operate in and clean laboratories. So all of these things together are going to help us greatly understand not only our asteroid, but its parent asteroid that it broke off of and others like it as well. So I have a little bit of a spoiler alert that happily we think we collected much more than 60 material, and that is going to, well, the asteroid that we traveled to, was named our spacecraft. It was known as Asteroid 101955, 1999 RQ36. So that's just the next sequence in the list of asteroid discoveries. Doesn't really roll off the tongue too well. Thankfully, it qualified to have an actual name. So we held a contest for school kids, and 9-year-old Mike Puzio's entry won out of 8,000 entries. And again, I have to confess that I'm so glad I didn't have to make that decision. We pretty much wanted a name that was a noble name, a nice name, not one of those evil mythological creatures. But it did need to be some sort of Egyptian creature. And in the end, Mike suggested Bennu, which is a beautiful bird, and it's actually associated with the god of Osiris. So it fit perfectly. And I'm happy to say that Mike is now getting ready to go off to college, and he's been following the mission all the way through. So it's been wonderful to get to meet his family as well. All right, so what about more names? Well, all of the features on asteroid Bennu are named after mythological birds. So when you look at different myths from different cultures, but they're all named after birds. And even our proposed, we named after birds. Now they weren't mythical, you know, a nightingale is a real bird. But those were just our working names until we had official names. So the Nightingale site is actually where we collected our sample. So this is a mosaic of Bennu as if it's been stretched out, kind of like a map of the world that you might look at. Instead of a globe, we're looking at it stretched out. And it's a pretty amazing world, I have to say. All right. So why did we choose to go to an asteroid? Well, because they're the first solid bodies to form in the solar system from dust and gas. So in the upper right, you just see a nebula, and since you're amateur astronomers, you know what a nebula is. And the solar system formed from nebular fragments that came together and became gravitationally associated, and eventually, actually fairly quickly, really, formed the sun and solid materials formed in the solar system as well. The asteroids are leftover pieces of that beginning of the solar system. Many of those dust grains and gases coalesced into little pebbles and bigger rocks and bigger objects known as asteroids or minor planets. In recent years, we've discovered that some of those asteroids may have moved around throughout the solar system a little bit because of the gravitational field of Jupiter and Saturn. We're still investigating that idea, and the material we bring back from Bennu may help us understand that as well. But about 3.9 billion years ago, we know that there were many more asteroids that collided more frequently. And we see that actually in the meteorite record and the record of impacts on the moon. The Earth would have lots of impacts like the moon, of course, if we didn't have an atmosphere and an active geology to erase that evidence. But the meteorites preserve that evidence. And so each one tells a story of a different place and a different time in the solar system. Over there in between Mars and Jupiter is the asteroid belt, and that's where Bennu is located. And that's rather than one object that broke apart, many of these objects formed independently. So they're very interesting objects. So where exactly is Bennu located? Well, see here, entirely to be a potentially hazardous object. Thankfully, it's for the at the same place to understand how asteroids that normally reside in the main asteroid belt migrate inward to the inner solar system and become potentially hazardous asteroids and perhaps even meteorites. I should point out too that meteorites in our laboratory collections are truly representative of the asteroid belt. All we know is that these are the objects that have collided with Earth. We do think that some of the carbonaceous or carbon-rich meteorites are very fragile and don't survive. So it might be that more have hit Earth, but we just don't find them because they dissolve. And certainly in your part of the country, as soon as they hit the ground, the rain and snow start to break them apart. So I like this picture because it was taken by an amateur astronomer named
Dolores.
Favorable. Yes.
You are breaking up sometimes here.
Oh, I'm sorry.
And on my screen, it says your bandwidth is low.
Oh, okay.
If you're displaying all of the participant screens, you may go to speaker view only and help with your bandwidth.
Okay. We'll give that a try.
Okay.
Let's see. We don't want that. Oops. Okay. Let me back up here. Sorry. Okay, so small active speaker, thumbnail video. Let's see. Nope, that's not what I wanted to do. Okay, let me go back. New share more. How about more? No, oh dear. Trying to find my view screen, my view choices here. Okay. No, that's not good.
Yeah.
Let's see. I don't want to mute myself.
No,
Hide thumbnail
don't want
video.
you
Okay, let's
muted.
try that.
You may
Okay,
have
maybe
a view option in the upper right or upper right corner of the screen.
yeah, I see. Talking Dolores, show small active speaker video, thumbnail video, and grid video. Okay, there's more.
That looks like the right place
Okay.
to start.
Does this work any better, you think?
Yes.
We'll give it, okay, we'll give it a try. Okay, thank you. So this is what asteroid Bennu looks like from Earth. And don't bother to look at it with your telescope because it's normally between 18 and 21 magnitude. So that's pretty faint. But Peter Lake had a very large telescope and was able to image Bennu for us. And indeed, we studied it quite a bit before we selected it from all of the asteroids known. However, one interesting thing, okay, why? There we go. One interesting thing is that when Bennu was approaching at its closest approach to Earth, it turns out that the Arecibo radio telescope was able to ping it with radar. And so what it did is sent a radar beam out to Bennu, and it would turn those timings into sort of a shape that you see on the left. And then they would take that information and transform it into a shape model that you see on the right. And so that allowed us to understand that Bennu was about 500 meters across, and that's exactly what we measured when our spacecraft arrived, and its shape. In addition, even though the astronomer that did the work actually did detect one of the largest boulders on Bennu during these observations. So this gave us a great advantage to help us understand how to approach the asteroid and navigate. And so this is what we saw as we arrived. It was a little disconcerting. Yes, it's about 500 meters across, but oh dear, it has huge, huge boulders on the surface. Some of these are bigger than a house. And we were expecting, based on our models, we were expecting rocks maybe 10 centimeters or less. So that's maybe, that posed quite a challenge for us. But we did know that a lot of the data that we would acquire would help us understand our models and adjust our ground truth information all along, including those big boulders. So that caused us to change our rationale a little bit. One interesting thing, we don't normally brag about visiting small objects, but in this case, our spacecraft approached and orbited the smallest object ever orbited. And so we actually are in the after that record. So that was just kind of a fun achievement. So here's how we acquired our sample. This is what we determined before we launched. The tag SAM, or touch and go sample acquisition mechanism, approached the surface much slower than in this animation. We touched the surface for only a few seconds and put the capsule, put the canister away in the airspace towards Earth. And so we technically did not land on the spacecraft, didn't land on. Okay, so let me show you exactly how we were able to collect the sample by touching rather than landing. So this is an early test of Lockheed Martin's tag SAM device. And it was tested on what is known as the Vomit Comet. And this demonstrated that the technique would work in a low gravity environment. So it touched the surface, fired some high purity nitrogen gas, stirred up the material, and it got trapped in the canister. And so this proved that it would indeed work. Our ideal sample was 2 centimeters across. We could, if we had to pick up material as big as maybe 6 centimeters across. So on the left here, you see what is actually going on inside. The gas stirs up the material. The gas flows out of the mesh and the rocks get trapped inside. There's a one-way Mylar check valve that traps material. I do think this animation is somewhat amusing because it was a surface that was fairly strong, and you'll see shortly how that was not what we expect, not what we found. All right, and just for fun, other talks. And so this is what is known as a contact pad. At the
Dolores, we seem to have lost you.
Also, Dolores, you're
Dolores,
muted.
Can you hear me?
Unmute yourself, Dolores.
Do that from here.
Is that better? Can you hear me now? Okay, sorry about
hear you
that.
now. You disappeared for a while.
Okay, says my internet, says my connection is unstable. Sorry about that. Okay, so we'll start here. So here's a close-up of one of the contact pads, and there was a whole series of these pads on the bottom of the tag SAM head, and these were meant to trap particles and be our contingency sample in case for any reason our
Laura,
tank of
I believe
high
your
purity
screen-
nitrogen gas.
You lost the screen share.
Oh, sorry. Okay. Share. How's that? Are we good?
Oh,
We see you.
You don't want to see me. Screen.
That's all we see is you.
No?
We're seeing a lot of participants and not your PowerPoint or whatever that is.
Okay. All right, let me exit here and we'll start fresh.
Okay.
Share. Okay, you know what? That's the PowerPoint share, not the Zoom share. All right, let's go back here. Zoom. No, we don't want to do that. Okay, so I see myself, I see one person, there's stop video. We don't want to do that. Exit minimized video, there's, okay, that's looking better. I don't, it says stop video. Do we want to do that? No. I don't see an option to share. There we go. Share screen. Okay. All right. I think we're back.
Just about.
Okay.
We have an indication that you're sharing, but I don't see the,
Oh, okay, there it comes. We can see it now.
Okay. All right. Okay, very good. Sorry, but I think I'm going to be, but this is a contact pad close up, and it was meant to trap little tiny particles in case the nitrogen didn't fire to stir up the rocks. But there's no way we were going to come home empty-handed. So it helped us understand how much sample we collected. So this is how we're coming home, September 24th, 2023. And we are going to the sample return capsule over range. The shield will protect the sample inside from heat, moisture, and oxygen. And it will land with a bit of a thud. Unfortunately, I'm told it will land at about 100 miles an hour, but the sample will be protected inside. And we'll be to center, where we have a brand new clean room devoted just to our sample. Kind of fitting because right around the corner is where the moon rocks are stored. So it feels like a wonderful full circle for us. All right. So what in the world have we discovered so far? First thing we discovered as we approached asteroid Bennu were boulders up to 60 meters across. So that's an impact craters, and I'll show you some pictures of these shortly. We right off the bat discovered, yes, there is water locked up in the rocks. That was a very exciting discovery. And we've discovered minerals that have been transformed by water. That is a significant amount of water. Phyllosilicates, which are clay minerals, and magnetite. So selected has had some melted water flowing on its surface. Bennu is a close match to some meteorites in the laboratories, and yet it still has some differences as well. The sun's radiation on Bennu's black surface causes its day to speed up by 1 second per year, and we actually measured that, and causes its position to get closer to the sun by 131 feet per day. And this was the first time anyone had ever measured both the Yorp and Yarkovsky effects. So that was very exciting. In addition, So that was kind of fun. But one of the most surface, and these have never been seen anywhere in the solar system. So it was very exciting. Discovered that Bennu's surface is not only composed of loose material, but it is so loosely held together, like a bunch of balls at a kid's plastic ball pool where you just jump in and all the balls roll around. And that's essentially what we found at asteroid Bennu. It looks like a solid surface, but it is just barely held together. So here's some of those particles. This was discoveries ever discovered by Carl Hergenroth by accident. And I love this story because he was looking at navigation images for fun, good image. Amateur astronomer at heart, wanted to identify the constellations in the background and the star clusters. And he did okay until he came across this cluster of spots. And he couldn't identify the star cluster. He knew it had to be something very bright, contrast, and the gain, and realized, oh, and this is what we determined. That there are particles being ejected from asteroid Bennu. Some of them fall directly back to the surface, some actually orbit a few times, and others are ejected off out into space. Bennu's escape velocity is only 0.3 meters per second. So you could pretty much just jump off the surface very easily. And so that's what these particles did as well. We didn't know what caused these, and we wanted to make sure that they wouldn't as much as 10 centimeters across, but moving slowly, so they wouldn't pose a hazard to the spacecraft. At first, we thought, oh, it happens on the hot sunward side when the rocks are being heated up, and they break apart from freeze thaw action. And then we determined that it was a combination of fractured rocks from heat thermal stress, as well as we did
Dolores, I think we've lost you again.
meteors on the Earth and didn't really find any that we could connect for sure. But we did pull of Bennu much more precisely. Are you able to hear me now?
I am hearing you now,
but
Oh,
you were breaking up quite a bit for a while.
okay. Oh, now it says I'm unstable again. Okay, we'll try it again. So these particles are ejected from the surface where we can't predict where they occur. And we only discovered them by accident because of the orientation of the cameras. We asked our colleagues on the Japanese spacecraft to a different asteroid if they had ever seen anything like this, but they didn't have the correct orientation to see them, so they couldn't confirm or not. All right, so on asteroid Bennu, you see it is a pretty rocky place. The largest crater in the red box is about 400 feet across, and that was large enough that it could have broken apart the asteroid, but for whatever reason did not. Here's another image of a boulder field, and you can see that a rock that are the size of only a few inches across. So this was a huge for us to figure out a safe for different kinds of rocks that we encountered. We have bright, smooth rocks that have high thermal inertia. That means they don't share their heat energy very easily. And yet we have dark rocks or cauliflower rocks that have low thermal inertia. Measurements tell us that's the opposite of what they would expect. In addition, we found significant bright material on top of boulders that so that light
Dolores, we have lost you completely again. Dolores, can you hear me?
Okay, I think we're back. I'm sorry about this. I can hear you. Can you hear me?
I can hear you now.
Hear me?
I can hear you now, but you are not sharing anymore.
Okay. Oh, okay. Let's do that again.
Is this showing she's muted?
Okay, unmute. Now, share. Okay, I think we're back. Can you hear me?
I can hear you. It looks like your sharing is still downloading.
Good.
Oh,
There we have you sharing.
Okay. Okay, I guess it's just slow. Sorry about that. All right, so one thing that intrigued us are ridges and slopes on the surface that show a tremendous amount of rock movement. So this red circle was our original plane
Dolores, you
that
are
needed to
breaking
be
up again.
smooth, sampleable, and you can see it okay.
Anything else working all day, she could turn off.
Dolores,
Okay, let's try.
if
Am I
you have
back?
anything else running on your
Yes.
computer, you may have to turn it off if it's something else that's also accessing the internet.
Or if there's another computer. Or cell phone, maybe. TV.
Yeah. Well, shouldn't actually. Okay, I'll take a chance and close that. Okay.
Okay, we hear
Can
you
you
and see
hear
you.
me?
Yep.
No. Okay. You can hear me? Okay. Do you see my slide?
We hear you and see your sharing.
Can you see the slide? Okay. Okay, good. The green circle, thankfully, they could work. Am I gone again?
You went away for 3 or 4 seconds
Okay.
there.
So, okay. Let's see if we can, there, does that work better? So this green circle is what turned out to be acceptable. So now we'll try to take a flyover of the Nightingale sample site before we collected our samples, and yet this was one of the best sites. That slight middle depression there is the area that we collected our sample. So we needed to get in and out without any part of the spacecraft touching the surface. So our navigation team had to plan our approach and our exit very, very carefully, and they did a great job. Okay, so what a difference 2 dimensions and 3 dimensions makes, right? So I'd like to just give some kudos to what our asteroid is made out of. They used 10,000 spectra and thousands of images to help figure out what every part of the asteroid was made out of. And in the end, they were able to determine that most of the surface has those phyllosilicates, and that's what we have in black, and in red is laboratory spectra, and in the lower right, those 2 red peaks coincide with magnetite. We were able to, and Bennu is the dark spectrum at the top. And you see most of these are just little squiggles, but it turns out it's CI or CM meteorites. Here's that water band that I've been talking about. It's at 2.7 microns, and we were very excited to see this. This is what we expect Bennu to look like, very black. It only reflects 3% of the sunlight that strikes its surface. So now I'd like to show you what really occurred in the tag maneuver, or the touch and go maneuver. So here's our tag surface. And you can see we disturbed a little bit of the material, moved some of the rocks around, cleared our nitrogen gas and the thrusters that we made a huge difference and actually made a 9-meter crater. Once we collected we looked at fortunately, you see all of those little specks in the picture are evidence that we were losing material. And that gave us considerable heartburn. Originally, we were going to rotate the spacecraft empty and then full, and the difference in the angular momentum would tell us the mass that we collected. But once we saw that material was leaking out of the collector, we realized we couldn't do in the left-hand inner part of that ring, you might see a little bit of a bulge. That's where a rock held open the mylar flap and was allowing material out. So a decision was made to just very quickly, safely stow the sample, and we would use pictures to figure out how much we collected. And here's where you see those contact pads as well. We do estimate that we collected approximately 250 grams instead of 60, but the error bars are pretty high. There's plus or minus 100 grams. So we put the sample away. This is what the sample return capsule looked like. We had a camera trained on it to make sure everything went well. And this was excruciating. It took several hours for this process to occur. A command to move a few millimeters, and then we'd wait, get the confirmation, move a few more millimeters, back and forth until we were all safe. So there it is, safe and sound, with the lid closed, ready to come back to Earth. Another thing I'd like to point out are these 3 little dots in that beige area. Those are witness plates to help us understand any sort of contamination that the sample might have experienced. So here's the real crater, and the thing to notice here is how much the rock in the middle moved. So where the X is where our collector collected our sample, and we actually propelled at least one rock almost 12 meters away. So it did the trick. And we also uncovered dark material that we expect to be finer grained and more delicate than the top surface material. All right, so this is a reconstruction based on real data. And look at that topography. It's pretty rugged. There we touched, and we think that we actually penetrated far into the surface before we ever fired our nitrogen. In our spacecraft pictures, you can see a huge amount of dust and debris that was blown up into the cameras. So our entire procedure did create a 9-meter crater that we went back later to study. So Bennu was more fragile and friable than we expected. So when we get the sample back, we are expecting a lot of powder, unfortunately. So here's another view that shows how much we excavated in that crater. So the point of impact is actually the point where we touched. The blue indicates material that has been removed or excavated, And we actually could see evidence of each of the thrusters in the pictures. And that striped bar at the bottom just indicates the diameter of the crater that was made. So this is called the TAG reconstruct, as we tried to understand what occurred and how well the TAG SAM operated. This is the first time this technology has ever been used, and so it may be used on other asteroids as well, perhaps even the moon. And so many of the world's meteorite laboratories are waiting to receive samples to analyze, and even new instruments are being built just for our sample. At the University of Arizona, we have special clean rooms and instruments that can analyze very, very tiny, tiny samples to maximize the amount of information we get out from it. So with that, I'll tell you what we have next. Once we eject the sample return capsule, the spacecraft, assuming it's healthy, can go on to another target. And indeed, NASA has approved an extended mission called OSIRIS REx for Apophis Explorer, and it will go on to asteroid 99942 Apophis in 2029. And the plan is to use thrusters to mobilize some material and try to understand the strength of that asteroid as well. So stay tuned, there's more to come. Thank you very much. Take any questions you might have.
Thank you, Dolores.
You're welcome.
Okay. Okay. After your last disconnection, I think I figured out something just watching my screen here, and that whenever you switch to a new slide that had a high resolution requirement, particularly the ones showing surface features on the menu, it took your bandwidth for a while until the slide downloaded, and then we started hearing you again.
Oh.
I caught that because your slides seemed to be delayed from your talk. So
Okay.
I think that's what was causing you to break up, and apparently a couple of your slides were enough that caused you to lose the connection.
Okay, if needed, I can go back.
Yeah,
and
we can take
refresh.
any questions now. Turning on the chat feature here. Okay, these are some chat comments that were relating to the lost connection.
Dolores, I've got a quick question for you. Later this year, NASA has another satellite that you're going to be launching against another asteroid. This one has a small moon. That satellite's going to hit the moon and try to deflect it and see if they can get it to slow down a bit. It looks like Bennu, because it is such a loose material on there, it looks like it's quite possible that when that satellite hits that moon of that asteroid, that it's going to have the same effect. It's going to be so loose, it may not slow it down at all, or very little. So if you have information on that one, which is coming up, and that should be a little later this year, I understand that's going to happen.
Right.
I'd like to hear it.
Well, so the first thing is that I believe when that asteroid was selected, they didn't know it had a moon. So that's kind of interesting. And you're right, that because we haven't had the advantage of flying by that system already, we don't know what to expect. So it could be very friable material like Bennu and just kind of fall apart, or it could be intact material and actually be able to push it into the main asteroid. So I think, the astronomers do their best, but they have limitations because all they can do is look at a dot of light and look at the light curves and how the spectra fit their models. So they don't have the benefit of gravitational fields and laser altimetry to understand the surface. So they're a little more challenged. We were able to spend a significant amount of time around Bennu, and it won't surprise you, the scientists wanted to spend an extra year, and the engineers said, no way, no, we need to get in there, get your sample, get back out, no delays, because delays mean risk. So in this case, there's more uncertainty as to what they'll find. I hope that answered your question.
Yes, it does. From what I understand, they're looking at methods that might be used in future if we ever have to deflect an asteroid.
Yes.
So it doesn't hit Earth's orbit and hit us. That's
Right.
one of the reasons they're doing this. So it'll be very interesting to see what happens when they hit it. Thank you very much.
You're welcome. And it is thought that perhaps the easiest thing to do is to give it a gentle push. But you need to make sure you don't push it into a worse orbit too. That's why we need to study them before they get that close.
Okay, do we have any other questions?
I have a comment.
Okay.
My name is Dave Smith. I was one of your Bennu mappers.
Oh, wonderful. Thank you.
You're welcome. That was a wonderful experience. It's just watching your slides tonight was like revisiting a favorite national park.
Yes. Well, and we had to extend that campaign because there were a lot more rocks than we ever expected.
Yeah, it was extremely rugged. I was really surprised. And once I figured out the scale, it was just surprising.
Well, and thank you so much. We needed all the help we could get. So we definitely appreciated it. Thank you.
You're welcome. Thank you. I was wondering when OSIRIS REx got to Apophis, are you going to have a similar mapping program for that?
I don't know at this point. It's possible they might, but I'm not familiar with it if so. All I do know for sure is that we can't collect another sample.
Right.
We had one tag SAM, and that was it, and one sample return capsule. But if the spectrometers and cameras are all working fine, there's no reason not to use them. So there could be another campaign. Why not?
Well, I'm available.
Thank you.
Apophis has a special interest to me because that was the first asteroid project that I worked on with the Planetary Society.
Oh, nice.
Years ago, with proposals on how to deflect it.
That's great. Thank you. Well, and some of you might be interested in the Target NEOs program. It started off as Target Asteroids with OSIRIS REx to support imaging asteroids that are like Bennu, but brighter, thankfully, to characterize them and help figure out what they're composed of just from the light curves. And we have transitioned to an Astronomical League program. So now you can earn certificates and pins for observing a certain number of asteroids. And Carl Hergenrother is my co-lead. And we've made sure to select some asteroids that are are within reach of small telescopes. And indeed, we have Ceres on the list. So that's the biggest, brightest asteroid there is. So check that out too.
Okay, thank you. Are there any other questions for Dolores tonight?
Thank you very much.
Okay, thank
Great
you.
program.
Thank you, Dolores.
Thanks for your patience with all the technical issues.
Happens.
Well, hopefully not a second time. So thank you very much.
Thank you very much, Dolores, and we will then move on to the rest of the program here. Okay. Next, let's move on to any observations by members. Al, I believe you have some ready to share.
Yeah, let me,
Stop here. Can you still hear me? Yeah, you can hear me.
Yeah, we can hear you here.
Let's see here.
Al would like to see your photograph of Pluto that you took Saturday night.
Well, let me see if I can get there. I'm not sure I have these in any kind of real good order. I've got some pictures here. This is a group photograph from Miami Zoo. It's normal observation, public, observing session that we have in Niagara Zoo the third Saturday of every month. And when was that? That was like June 16th, I think, or something. 19th, 19th.
Okay, yeah.
June
When
19th.
the June NIAMI session.
That was a good session. You can identify the PAC members because most of them either have blue or yellow t-shirts on. So we had quite a few. Then these aren't in any particular order, but there was a planetary alignment people probably heard about, and I made an attempt to take some photographs of that. And you probably have to take my word for it. Mercury's right down here. It's a little tiny dot. I don't know if you can see it. That's been on it now, you can probably see it. There's a little tiny dot right there.
Yeah.
And Venus, of course, is much more pronounced. And like I said, these are not in any kind of particular order. This was at the Eldridge Public Library in Eldridge, Iowa. This picture here, I think this is one of Byron's pictures. Byron, are you on the line?
Yeah, that's the pelican. You can see the pelican's head there.
Where's the pelican's head? is that here?
Yeah, you can see like the eye and everything right there. You got it.
Yep.
Mm-hmm.
Yep. Bright stars. That's nice. Very nice. And this is another one of yours here.
That was with the moon the other night. That's NGC, was that 6712 and IC 25?
1295.
What's that?
I think it was 1295.
1295. Yep. The little green haze in the center is a planetary. So that's a 2-for-1 shot.
I tried to do that too, Byron, but I couldn't get it in one frame because my photo length was too great, but I did find it. Nice.
Yeah, that's why I was playing with that filter. I was trying that nebula filter on the T3i unmodified. and that really took out the moon's glare.
Yeah, this is the Swan Nebula.
If you ever want a good nebula filter, that DGM is outstanding.
And I think this is Swan Nebula too, and I think this one came from Roy. He's using that, was he using the Stellina? I think it is. And that does a pretty credible job too. And I think this one's from Roy also. I don't remember what this one is. I've seen it before, but I can't remember what it is. Anybody know?
M82.
Is this M82? It's a galaxy with, looks like it's got a dust lane in there. It's pretty incredible picture. And this was a picture of the sun. I don't know what. Oh, this was on June 22nd. There's some nice sunspots there. That's a close up of it. This was taken with my telescope, just a white light filter on it. Not too bad. That was that group. And you were asking about Pluto. Oh, before I do that, I'll show you this too. I put together a composite picture of planets. So this is all the planets except Mercury, Venus, Uranus, the Moon, Mars, Jupiter. Neptune's there, but you got to use a little imagination to see it. Vesta was actually there. I was amazed in this picture. It actually shows up.
Yes.
And Saturn.
And this is the picture that was in the local newspaper this morning.
Oh, yeah.
Yes, you made it in the newspaper.
And I had different ones here. Here's another one here. This was taken a little bit later with Mercury down there, but then you can't see the other ones. It's too bright. Let's see. Then Saturday night, we were with us met at the Paul Castle Observatory. It's Cody, Rusty, Whalen, me, Byron. And these are just some of my shots. I was trying to shoot open clusters. Of course, the moon's out there too. So when the moon's bright, take a picture of it. Actually, it's kind of pretty. Okay, Byron. There's my picture. I had to kind of put together two of them to get your globular and planetary in the same image. So actually, and okay, right there. I don't know if you can see it. Pluto is right there. You have to take my word for it.
How can you else?
It's right there. Well, I've got another picture I could dig out from the week before that, and that was not there. It was over here.
I'm not doubting, I just wondered how that.
Yeah. And also, if you pull up Stellarium, it shows it exactly in that position. So I'm impressed with Stellarium. It actually is pretty accurate. So the only way to really know is to take another picture a couple of days later.
Right, which is how it was discovered the first one.
Right, right. And that's pretty amazing when you think about it. This is with pretty much a very bright moon out there, and this is like a 14.5 magnitude object, and you can image it even with a bright moon I was a little skeptical that it would be that easy to get. It worked. This is kind of cool too. This was Saturn. And it was really kind of amazing that these three inner moons were flying almost in a straight line. Really cool. This object here is a star. And this bright one up here is a star too. Iapetus is the little one here next to that star. It's not associated with the star. It's a satellite. I've got some others here. I don't know. We went out to we went out to Yankee Observatory on the 1st of July. The group was there. That's me. That's Roy, that's John Baker. And who are these guys? Darren, you told me who they were, and I forgot now.
What's Brett? Now I don't remember his uncle.
This is his uncle. Yeah, that's his telescope.
Terry.
Terry.
Eric, yeah.
Terry.
And Byron. We had a lot of fun there too. I was imaging open clusters and satellites. Lots of satellites. And 13, 22. I thought this was cool. You can see Andromeda Galaxy over the observatory down. And Milky Way is really pretty incredible out there. Even though there's a lot of light pollution here, you can still see it. Oh. We got Pluto here too. That was that's my image of extremes. And that's what happens when you try to use something too far south. And I had one here, Pluto here too. But I don't know. This was, when was this? June 26th or 27th, something like that. We were at Paul Castle, Rolly, Camino was there, Brian Racer, Rusty, and I. That's Rusty's scope. I was doing clusters again. There's M27, 50, M51. I think that's, this is M92. This is M1. It's more. There's a cluster there. You wouldn't know that I have a narrow. Does anybody else? I tried to get everybody's pictures and put them in here. Did I miss any, or does anybody have any others they want to share?
I think you already showed the ones that Roy had sent to me.
Yeah.
So, I think I have any other new.
If anybody wants to join one of our observing sessions, I mean, they tend to be a lot of fun. Sometimes they're frustrating. But most of the time it's fun.
Yeah, I think because of, much because of weather and other reasons, the observatory has been less used this year than it has in many years. And we have some nice equipment out there to use.
The observatory is fully functional and well equipped.
Yes.
So if anybody wants to use the observatory, let one of us board members know, and we'll, don't wait for us to suggest having an observing session. If you want to do something, make it known, and we'll try to accommodate it.
Usually one of the officers would be able to meet you out there if you are interested in doing some observing. And several of us have been trained in usage of the observatory scope. So all we have to do is let us know, and most of us, if available, would like to run out there and have our own observing session anyway.
Yeah, you don't have to twist our arms too much.
Okay, let's go back here to sharing my screen here. I can on the screen. Here we go. Okay. There are no other observations. Let's move on to future events that are coming up for the member meetings. In August, we won't have a regular meeting. We will have on August 13th our annual picnic. And hopefully we will be able to watch a Perseid meteor shower at the Paul Kessel Observatory. On September 12th will be our next monthly meeting here at Butterworth. And that will be our quarterly business meeting, brief business meeting, and followed by smorgasbord talks and observations by members. And this is your chance as a member to let Dino know. He coordinates the smorgasbord talks, and hopefully we'll have 4 or 5 of them available by members to present at the September meeting. In October, we have our annual banquet. It should be an interesting meeting. We will have Dennis Roscoe with the Next Generation Telescopes. We heard him at the National Convention in Port Washington, and he gave a very interesting talk, and we'll have updates on the James Webb as of October when he speaks at our annual banquet. So we should have more new things from him then. And he has some really interesting information about the bigger and better telescopes that are now being designed and built. And it was brought up to my attention today that there's a possibility of PAC members having a field trip in conjunction with the QCAS, and they're working with the Whitty Observatory near Burlington on that. So it's only been something that's proposed so far, but watch your email and our newsletter for any details that might be coming up on that. We have a lot of things happening on our public outreach schedule. Big thing tomorrow at the Putnam Museum in Davenport. Putnam is the first place in Iowa that will be receiving the first James Webb Space Telescope images. And they will be open at 9 o'clock, and the images are supposed to be coming in and displayed on their big screen starting at 9:30. And they're expecting about an hour of images from NASA, followed by some commentary on it. After that, they will have, the museum will be open, and from 11 until 4, they have invited us and other organizations to set up in their lobby and outside. We will be having at that some solar observing. We will have both a white light and hydrogen alpha scope there, and it looks like the weather is supposed to be good for that. We'll also have our planetary weight scales inside. Dino, I believe, will have some meteorites for display, and we will have a literature table in the lobby of the Putnam. That will be ongoing from 11 till 4. We have about 7 or 8 volunteers, but Putnam has said anyone who is a member of PAC and comes to volunteer to help us with our setups there, will have free access to all the James Webb activities there, including their big screen with the first images. As I said, the first images are scheduled to come from NASA at 9:30 tomorrow morning. And I said we started at 11. They're expecting that to be finished by 4 o'clock. They will have some additional activities relating to the James Webb after 4 o'clock too. And any of the PAC members are welcome to stay from that. Also in July, of course, after that on the 16th, on Saturday, we have our next Niabi Zoo public observing session. The following week, we are going to be busy. We will be at the Moline Library on the 19th, that's a Tuesday. They have a children's program and followed by a public observing evening from 7:30 until 11:30 at the Moline Library. So they usually get a lot of people out for that one. The next day on the 20th, Kewanee Library is having a space exploration day. Dino is going to be out there presenting some daytime information for them, and may have some solar viewing too if the weather cooperates. On the 23rd, Saturday, week from this coming Saturday, we will be having our public observing program at the Linowick Forest Preserve Campground. And this is the one that got rained out a few weeks ago. We're finally going to try it again on the 23rd. They're expecting quite a few people there. I was at a Linowick program just Sunday evening, and well, it wasn't astronomy, but they had about 300 people registered in the campground, and about 150 of them showed up there. So we could probably expect similar attendance, plus some attendance from Hampton nearby to participate in that on the 23rd. QCAS, in conjunction with St. Ambrose University, has a public observing also on that night at Menke. On the 30th, QCAS has scheduled a Perseid meteor shower party. I didn't have the additional information on that, but maybe
that's also at Menke this year.
At Menke. Okay, thank you, Jay.
Yes.
Okay, and okay, moving on then, we have on August 5th at Eastern Library in Davenport, they have a program called Reading Beyond the Beaten Path, and they are expecting a big group there for public observing. Again, in August on the 20th, we'll have our next Niabi Zoo. The following week on the 27th, St. Ambrose and QCAS will be back at Menke for public observing. And it looks like QCAS has another one on September 3rd. And is that at Menke too, I assume?
Yes.
Okay.
Yes.
And then that brings us back to September, Niabi Zoo again. And the big one coming up, Eastern Iowa Star Party, September 23rd through 25th. Information from QCAS on that, hosting it at Menke. The Cordova Library this year has planned to have their public observing in early October. They have not set a date yet, so I just said early October for that. We still have to determine the date for that, but they want us to come out there again. The Girl Scouts have asked for a program at one of their campouts, really a semi-public, not really open to the general public. That'll be on October 8th. We have another October Niabi, and then in late October we get busy again. Kewanee Central School, as a family event, they are tentatively scheduling for the 20th. The next day, Cambridge School has tentatively scheduled that for the 21st. I haven't heard back the final confirmation on all of those yet. So we have a lot of things coming up here. Okay, are there any other announcements for tonight? I do have one. I have a note somewhere here. Yes, received the confirmation from the John Deere Birdies organization that we have received 175 in pledges to the Popular Astronomy Club through the John Deere Birdies for Charity. And of course, we will be receiving that plus a bonus guaranteed to be at least 5%, maybe a little bit more, that will be credited to us when they finally do all the bookkeeping and get all the pledges in. Do we have any other announcements for tonight? If there are none, I want to thank all of you for participating online and here at Butterworth. And usually it takes me about a day to, well, it might take a couple days today. Tomorrow I'll be busy at Putnam all day. So maybe by tomorrow night, I'll be able to get the recording available, and I'll send out an email announcing where that can be viewed as soon as it is ready. Don't forget, we have IABI coming up on the 16th and again on the 20th. Don't forget our picnic on August 13th and our next meeting here on September 12th. Your chance to give a smorgasbord talk to the group. So if there's nothing else, I believe that's all for tonight. So just remember to keep looking up.
I gotta say hi to Franklin there real quick.
Oh, okay.
Yep. Hey, Franklin.
See Franklin?
Okay, yeah. Pull up the other screens there.
There's Franklin.
Okay.
He was there for a moment.
Yep, there's Franklin.
Okay. And that will conclude the program.